Good morning, students. Once again, welcome to secondary mathematics. Today we are looking at Form 2 and Form 3 quadratics. Welcome you. We have met quite some time, and you still remember my name. For the new viewers, I'm Teacher Elphas Ndenga. And once again, I want to ask that we get ready with all the resources that are required for this topic, so that we can be able to actively participate in the program. One of the important things that you must have at this time is a calculator, because we are going to make use of it, and then ensure you have your graph book so that we can draw together. Welcome. Now, even before we draw the graphs, this topic, quadratics, is captured in Form 2, and in Form 2, what we first look at is what we call quadratics expressions and equations 1 and equations 1. And in this topic, the first most important thing is for us to differentiate between a quadratic expression and an equation. And we say that a quadratic equation, that is an expression, is given in the form ax squared plus bx plus c equal to 0. This becomes an equation. And for an expression, ax squared plus bx plus c, this is now an expression. But the most fundamental thing is that a quadratic expression or equation is where the highest power is 2. So when the highest power is 2, we call them quadratics. When the highest power is 1, that is now covered in Form 1, we call them linear equations. So we develop from linear equations in Form 1. Form 2, we look at quadratics. Again, Form 3, we look at quadratics. And then we bring in a new concept of cubic graphs. And then, for example, we can talk of something to do with 2x squared plus 3x minus 7. This is a quadratic expression, of which 2 represents our A, and 3 represents our B, whilst negative 7 is our C, because A, B, and C should be constants. If we bring in an equation, for example, we can talk of 5x squared plus 3x minus 5 is equal to 0, then this becomes a quadratic equation. But without an equal sign, that is a quadratic expression. And these are covered in Form 2. When you go to Form 3, we now stop looking at more of the equations and expression, but now bring in what we call functions. So we talk of quadratic functions. A quadratic function is now given by the y is equal to ax squared plus bx plus c. And the functions are the ones that we draw. So we draw the graph of functions. We draw the graph of quadratic functions. We draw the graph of quadratic functions. That is to mean, for example, we can have y is equal to 2x squared plus 7x minus 5. We will draw this as a function. But now when it comes to solution, when we are now solving, we solve a solution of quadratic equations. So you should know that we draw functions but solve equations. And that is why we want to look at this aspect of quadratic graphs and their solution, so that when we draw a quadratic graph function, how do we solve an equation using a quadratic graph function? That is what we want to learn in our lesson today. And this area is very important for those who are taking the subject 1-to-1. And in this case, specifically, when you're looking at section 2 of mathematics exam, we are usually given graphs to draw. And we keep on alternating depending with the year. We can have a year when we draw the quadratic graph. We have also what we call cubic graphs that can also be drawn. So this change happens, but usually in section 2, because it takes some more steps that will give you more marks, that will require about 10 or so marks in section 2. So I want us to look at some of the questions that have been tested in this part and use them to illustrate what we need to do in the drawing of graphs. But one of the most thing is that when you're drawing a graph, these are the things that you must be able to note. That number one, you must use a suitable scale. You must use a suitable scale on both axes. And when talking about both axes, we are saying here we have the y-axis and the x-axis. I believe we are aware that the y-axis is the vertical axis and the x-axis is the horizontal axis. It's the horizontal axis. So the scale has to be suitable for either the y-axis, either at above the y or below the x-axis, and again on the x-axis to the left or to the right of the x-axis. Then number two, you must be able to have or to use a suitable table of values. And in most cases, you'll be given a question with the part 1, which has to fill the table, and they will tell you that filling of the table will give you 2 marks. So that you get the correct values that you are going to use to plot your graph. These values are obtained, they are obtained from the function using the given values of x. When you're using the given values of x, we obtain the values of y by substituting in the function y is equals to ax squared plus bx plus c. And then after that, then we are able to plot and draw the graph using the values of x against the values of y. So you plot the graph using the values of x against the values of y. Finally, we also need to understand that when you are drawing the graph, it is quite important to know what happens when you're drawing the graph and what must you consider. And so one of it is that the scale, and that is why in the marking of this part, we will award the scale mark S mark. And this only happens for that person who has used a suitable scale on both axes. So for you to score this, you must be able to ensure that you followed what you said under the note. Number two, we'll award marks based on the B mark. And usually in the drawing, the B constitutes to both the method and the accuracy. So it must have both accuracy and you must have followed the right method for you to get the B mark. We are going to give you what we call the P mark. This is for plotting. When you plot correctly, we award a mark for plotting. Again, this one can be given in the case where you are filling the table. Filling the table. You can fill, by filling the table, we will award the B mark. And then we have the C mark, which is for the curve. This is for the curve. When you're drawing the curve, will give you now the C mark. So these marks, when they are totaled together, you end up scoring 10 or so marks in an exam of, that is section 2 of the exam. And in most cases, paper 1 exam. So with that now summary, let's look at questions that have been tested in this part from previous KCSE questions, and then work them out together. So the first question, that is in 2003. As you can see the question on your screen, you are told to, the question is that, that is in 2003. Okay. What we have is that complete the table of the graph for the function y is equals to 2x squared plus 4x minus 3. Y is equals to 2x squared plus 4x minus 3. And as you can see on your screen, the table is drawn with the values of x, with the columns, that is for x. We have the column for 2x squared. We also have 4x less 3. And then we have y. And the range of values of x from -4, -3, -2, -1, 0, 1, and 2. 0, 1, and 2. And they are filled for you 32, that is under the x, under 2x. Then we filled 8 under -2. Then we filled 2. We have 0. We have 2. We have -11, -3, 3, 13, and 5. So we are told to fill in the table. So let's see how do we fill the table. In this case, the function is y is equals to 2x squared plus 4x minus 3. And they have done it so well that they have grouped the part for 2x squared, 4x minus 3, and y. So when we fill this column, it means simply square -4, you get 16, times 2 gives you 32. We shall do the same here. Square -3, you get 9, times 2 gets 18. Square 2, that is 4, times 2 gives us 8. On this row, what we have is 4x minus 3. So we take 4 times -4. That is -16, minus 3 gives us -19. 4 times -3 is -12, minus 3, -15. 4 times -1, that's -4, minus 3, -7. 4 times 1 is 4, minus 3 is 1. Then we come to y. And y is supposed to be 2x squared plus 4x minus 3. So we'll start from this point. 32 minus 19, that is 13. Minus 3, that is 10. We have 18 minus 15. That gives us 3. We have 18 minus 3, then minus 3. That gives us 0. 8 minus 11, that is minus 3. Then minus, again 3. Let's do the changing here. We have 2x squared, which is 18, then plus 4x. 4x minus 3 is simply minus 15. And so this gives us -3. This is -3. Again, this one, we have 18, 32 minus 19. 32 minus 19, that is 13. Because -3 is already factored here, And then at this stage, we have 8 minus 11, that is negative 3. We have 2 minus 7, negative 5. 0 minus 3, negative 3. And then 2 plus 1 is 3. 8 plus 5 is 13. So those would be the correct values for y. 13, negative 3, negative 3, negative 5, negative 3, 3, and 13. So once we have this, then we draw the table, we draw the graph. So how will you draw the graph? We are saying the first thing is to draw the x and the y axis. So we'll draw the y axis and the x axis. And this is 0. Now using the values that we have, x is from negative 4 to 2. So the difference of 1, 1, 1. So we shall have 1, 2, negative 1, negative 2, negative 3, negative 4. So I can say on the x-axis, 1 centimeter represents 1 unit. That is my scale. And then the highest value on the y-axis is 13. So we can say, let's use the scale of y-axis, 1 centimeter to represent 2 units. So I will have 1, 2, 3, 4, 5, and 6. So 2, 4, 6, 8, 10, 12. Then we can have 14, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. And then now we plot. So at this stage now, we'll have 2 marks, B24, filling the table. Then we'll have B1 for the scale, which includes also drawing and labeling the axis, the x and the y axis. So that is positive 3. So now we plot the values. Negative 4, 13. Negative 4 on the x-axis. Y-axis is 13. Then we have negative 3, 3. Negative 3, 3. Negative 2, negative 3. We have negative 1, negative 5. We have negative 1, there's 0, negative 3. 0, negative 3. Then we plot 1, 3. 1, 3. And then 2, 13. 2, 13. By doing that, you will score what you call the P mark. So you get the P1 mark for plotting the values correctly. And so the marks for C is to draw a smooth curve. And I am hoping that my students are with me. And so draw a smooth curve. Join from, ensure you have the right turning points. So I will join. So that is our curve. Hoping that you have drawn the best curve because you are using your graph book or your graph paper. And that is what we call the curve. The graph of y is equals to 2x squared plus 4x minus 3. So let's see what are the questions now after we've drawn the graph. Okay, so as you can see now, part A of the question was to complete the graph, then part B were to draw, of which we've drawn, and then use the graph to estimate the roots of the equation. And the equation is y is equals to 2x squared plus 4x minus 3 to 1 decimal place. To 1 decimal place. So we need to get the roots. And the roots here, what they're simply asking, what are the solutions of this curve? And the easiest way to get these solutions, after drawing the curve, you get the points of intersection of the curve with the x-axis. So our roots here are simply points, or not really points, but values of intersections, values of x. That's where the curve intersects the x-axis, where the curve intersects the x-axis. So at this point, as an estimate, this is -2. So we can have -2.5. That is the values of x. And there's always a difference. There's always a range of values. So you can either mark plus or minus 0.1, depending with the accuracy level that will be given for each question. Again, this is 0.5. So x again is 0.5 plus or minus 0.1. So those will be the roots or the solutions of the curve y is equals to 2x squared plus 4 minus 3. Part C. Part C of the question, we are told to, in order to solve graphically the equation, 2x squared plus x minus 5 is equals to 0, a straight line must be drawn. A straight line must be drawn. So we are solving now the equation. 2x squared. We are solving 2x squared plus x minus 5 is equals to 0. So that is what now we call the equation. And we are supposed to solve this equation using the function. So what you do is simply subtract or add the equation that is from or to the function. I'm citing subtract or add because the essence of doing this is to eliminate the squared part. So if it seems easier to add for you to eliminate the squared, then you do the addition. Or if you subtract, you'll eliminate the squared, then you subtract. That is what we do in solution of quadratic equation. So here what we shall write is y is equals to 2x squared plus 4x minus 3, and then 0 is equals to 2x squared plus x minus 5. So we subtract this. Y minus 0 is y. 2x squared minus 2x squared, it's 0. 4x minus x gives us 3x. Then minus 3 minus 5 gives us plus 2. So the equation now is y is equal to 3x plus 2. This is a straight line equation. It's a linear equation, which we are supposed to draw. Because after subtracting, we now not draw the curve, but now draw a straight line equation that we have from subtracting the equation from the function. And in Form 1, you drew these lines. If you want to draw this line, what do? At least have 3 values of x and find their corresponding values of y. So if we have we can say we let x to be, let's have 0, manageable values 1 and -1. Then y is 3x plus 2. So I will be replacing in x as 0, then y will be 2. When x is 1, put here 1. This is 3 plus 2, 5. Then when x is -1, that is -1. So we plot those values on the same Cartesian plane. 0 and 2, you mark 0 and 2. 1 and 5, 1 and 5. And then -1, -1. Then you use your ruler to draw a straight line. Use your ruler to draw a straight line. So use your ruler. So that is the line. Y is equals to 3x plus 2. Y is equals to 3x plus 2. And once you've drawn, even before you are told what to do, get the points of intersection of the line with the curve. Because these are what will give you the solutions. And then you extrapolate to the x-axis. Extrapolate this to the x-axis. Extrapolate this to the x-axis. And those will become the solutions for your equation. So then you'll say x equal to, when you extrapolate to the x-axis, then you have this as -1.8 plus or minus 0.1, or I will say x is, this is 1.2, let's say 2 plus or minus 0.1. And those are the solutions to that question. So it is easier to do it as we've drawn and as we've explained how to solve quadratic equation, and in this case, when you've been given the table to fill. So you fill the table using the given equation and the values of x, and then from there now you can be able to work out the rest. Let's look at another question. Now a different way where you've not been given the table. So let's go to 1994. So in 1994, as you can see, you are told to draw the graph. You draw the graph of the function. We are drawing the graph of the function y is equal to 2x squared plus 6x minus 5. Y is 2x squared plus 6x minus 5. And you are not given any table, but you are told the range of values from -4 to 3. So we are drawing for the values of x from -4 to 3. So how do you now proceed when you have not been given the table? The first thing is for you to develop a table of values of x and y. So we will draw a simple table. Since we have the function, then we can have a table of x and y. So we have from -4, -3, -2, -1, 1, 2, and 3. And fill your values using your calculator again. We start with this part. 2x squared So I square negative 4, you get this is 16. Times 2, that gives you 32. So you have at this point 32. And this is negative 4 times 6 gives us negative 24. Then minus 5. So this is negative 8, sorry, positive 8 minus 5, which is 3. Do the same for this. Square negative 3, you get it 9 times 2, 18. Then negative 3 times 6, negative 18. Then minus 5, so this gives us negative 5. We go to the next case, negative 2. Negative 2 squared gives us 4 times 2, that is 8, plus negative 2 times 6, negative 12, then negative 5. So this is negative 4 minus 5, negative 9. Negative 1 squared gives you 1 times 2, that is 2. We minus 6 times negative 1, negative 6, then minus 5. And this gives you negative 4, this gives you negative 9. When it is 1, sorry, we've skipped 0. We can't do without 0 because it's part of the values. So from negative 1, 0, 1, then 2 to 3. So when it is 0, we replace here. This is 0, 0, negative 5. When it is 1, this is 2 plus 6, 8 minus 5, 3. When it is 2, this will be 8. 8 plus 12 is 20, minus 5 is 15. And when it is 3, this is 18 plus 18, which is 36, minus 5, which is 31. So those will be the values of y. Now, as you can see these values of y, there's something here, and this I will explain it when we get to the curve. Negative 9 and negative 9 for y. We need to identify something there. But before that, let's draw. Let's draw the curve. So we will draw the curve for this case. Ensure you have the y-axis, the x-axis drawn using a ruler. This is y-axis and this is x-axis. They must be labeled. Then label the point O or the mark 0. Then we have 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. The highest value of y in this case is 31. 31. So I will have, let me use a scale of 5, 5, 5, 10, 15, that is 20, 25, 30. Then you have negative 5, negative 10, negative 15. Then we mark or we plot the values of x against y. Let's plot the values of x against y. When x is negative 4, y is 3. So negative 4 against 3. X is negative 2, negative 3. Y is negative 5. Sorry, this is negative 5. Negative 2, negative 9. Negative 9 somewhere here. Negative 1, negative 9. At this point, same level. 0, negative 5. Then we have 1, 3. 1, 3 somewhere here. 2 is 15, then 3 is 31. So if we are to draw this graph, this has to be the turning point somewhere here, but it is not defined. So we have to get what is the turning point, because these 2 points are on the same level. So in between them, there is a point in between, that is negative 1.5. We now bring it to the table and find the value of y when x is negative 1.5. We replace it in the equation. Y is equals to 2x squared, negative 1.5 squared, plus 6, negative 1.5, negative 5, so that we are able to get what is the value of y. Negative 9.5, good. So this is negative 9.5 as our turning point. So I will mark it here. Negative 1.5, negative 9 is yes, so slightly lower, so that we have that as negative 9.5. And that becomes our turning point for the curve. I hope students are there. Now we can draw. Same thing. Ensure you have done your work at the turning point first. So if I draw my curve, then I lower this, so that becomes our curve for y is equals to 2x squared plus 6x minus 5. We were told to draw the graph. We've drawn the graph. What is next? We are using the graph to solve. We are using the graph to solve. We are solving 2x squared plus 6x minus 5. 2x squared plus 6x minus 5 is equals to 0, Roman 1. Then Roman 2, we are using the graph to solve 2x squared minus x minus 6 is equals to 0. So let's see how we work it out. Now, we are taught to use the graph to solve Roman 1, 2x squared plus 6x minus 5 is equals to 0. If you compare this equation with what you've drawn, they are the same thing. The only difference is that this is a function and this is an equation. So what we need to know is that what we are supposed to get here are simply the points of intersection of the curve with the x-axis. They will give us the solution. Because if you take it to subtract y is equals to 2x squared plus 6x minus 5, and this 0 is equals to 2x squared plus 6x minus 5, and then you subtract, you will have y, and on this side you have 0. So the line y is equals to 0 is the x-axis. This is simply the x-axis. So in short, what you are looking for is the points of intersection between the curve and the x-axis, which are the points of intersection of the curve with that axis. So here the solutions are this, negative 3. This will be negative 3. X is equals to negative 3.3 plus or minus 0.1. Or at this point we have 0.5 plus or minus 0.1. Those will be the solutions. But you should be having the more accurate values because you are using your graph books. For Roman 2, we are using again the graph, but now to solve, we are using the graph now to solve 2x squared minus x minus 6 is equals to 0. So in this case, subtract this from the function. The function is y is equals to 2x squared plus x minus 5. And then this is 0 is equals to 2x squared minus x minus 6. We subtract this. Y minus 0 is y. 2x squared minus 2x squared is 0. X minus x, that is 2x. Minus 5 minus 6, that is plus 1. So the equation now is y is equals to 2x plus 1. And this one is a linear equation. It's not quadratic. This is a linear equation. So what we need to do is to draw this linear equation, which is a straight line, on the same Cartesian plane. And how do we draw? Very simple. Choose any 3 values of x and find their corresponding values of y. So what we say is we let x to be, again, manageable values like 0, 1, and negative 1. Then have y is 2x plus 1. So when x is 0, replace it here. We have 1. When x is 1, this will be 3. And when x is minus 1, this will give us negative 1. So we plot these values on the Cartesian plane. We plot them on the Cartesian plane so that we have our line. 0, 1. 0, 1 is somewhere here. 1, 3. 1 versus 3 at this point. And then negative 1, negative 1. Happen. So we join using a ruler. Use a ruler to join and draw a straight line. And this is y is equals to 2x plus 1. That is the straight line. So once you have that as the straight line, it is very simple. Definitely they need the solutions of x. You get the solutions by looking at the points of intersection of the line with the curve. And then you extrapolate to the x-axis. You extrapolate to the x-axis. That is to mean that your x is equals to negative 2.5, either plus or minus 0.1, or x is a positive 1 plus or minus 0.1. Those are our solutions. So something good there is that we've been able to see when we have 2 points on the same level without a turning point, then you get it by looking at the point in between, replace it in the function to get the turning point. And then number 2, when you're not given the table, you develop your own table. Okay. Now, in our last question, we want to look at the question that, that is in 1993. That is our last question. And again, in that year, it was very brief. Very brief. On the grid provided, you are to draw or to plot the graph of the values of x and y. That is for the curve y is equals to 2x squared plus 3x plus 6. For the values that is from x is negative 3 to 4. That is the question. So we need to plot this graph. No table given. We'll do the same way, the way we've done for 94. We'll create our own table. We'll create our table for y and x. So we'll have this as y, x, sorry, and y from -3, -2, -1, 0, 1, 2, 3, and 4. So we get y. So you take your calculator again, and let's find the values of y together. X is -3. So it will be -3 squared, which is 9 times 2. That is 18. Then at this point is -6 plus 6. So the answer here is 18. Go to -2. When you replace it here, it will become 4 times 2, that is 8. Then at this point, we shall have, this is -9, sorry for that. This is 3 times -3, -9. And then we have, that is now 9 plus 6. That will be 9 minus 18 minus 9 is 9 plus 6, 15. Then this one, we have this as 2, and this is 4. That is 8. 3 by -2, -6, then plus 6. So this is where we have now 8. When it's -1, squared is 1. The question is y is equals to -2x squared. Thank you. -2x squared. -2x squared plus 3x plus 6. So if it's negative, now what you have is -2 into 9, that is -18. Then minus, that is 9 plus 6. So that is -21. Again, this is now 4. That is -8. Then plus -6 plus 6, -8. Now come to -1 squared is 1. That is -2 minus 3 plus 6, +1. Then this is 0, 0. This is 6. 1, this is -2 plus 3, that is 1. That is 7. And this is 4. Therefore, this is -8. -8 plus 6 is -2 plus 6 is 4. This is 3. This is 9. This is -18 plus 9, -9 plus 6, -3. This is 16. Therefore, that is -32. -32 plus 12 is -20 plus 6 is -14. So those are the values of x and y. And once you have them, go straight to the drawing of the graph. Go straight to the drawing of the graph. Because now we've mastered the procedure. Once you fill the table, then the next thing has to be the drawing of the graph before we do the solutions. So we will draw this is y, this is x, 0, -1, -2, -3, -4, 1, 2, 3, 4. The highest value of y is 7, and the lowest -21. So we can use a scale of, if I use the scale of 3, now let's use 2. This will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. I will drop it and then say this is 4. Let's have the scale 1 unit represents to 4 units. So -4, -8, -12, -16, -20, -24, 4, 8, 12, 16, and 20. Then we plot the values of x against y. When x is -3, we have -21. -21 somewhere down here. When x is -2, y is -8. -2, -8. -1, we have 1. And then 0, 6. 0, we have it as 6. Then 1 as 7. 1 is 7. 2 drops to 4. Then 3 is -3. And 4, -14. That is 12, 14. So that is our curve. And so we go to the drawing, joining the turning points. So I will have to draw that is my curve. Y is equals to -2x squared plus 3x plus 6. Y is -2x squared plus 3x plus 6. So once we have that as the curve, now we need to see if there's any question. Do you have any question? We are told to use the graph to solve. -2x squared plus 3x plus 6 is equals to 0, or simply solve the -2x squared minus x plus 9 is equals to 0. That is what you are using to solve. And so what we do in this case is we subtract this from the function. We said y is equals to -2x squared plus 3x plus 6. And so we have plus x. So we have y, 0 is equals to 2x squared plus x plus 9. So what we do now, let's see what do we do. In this case, we will not subtract. That's why I said somewhere you either subtract or you add. You either subtract or add. So here we are not subtracting, because if I subtract, I will still have x squared. So we add, so that this is y, and this is 0. This becomes 4x, and then this becomes plus 15. Then we do the same procedure. We identify any 3 values of x. So let x be, let's say 0, 1, and -1. And find the values of y, which is 4x plus 15. When x is 0, this becomes 15. When x is 1, 19. And when x is -1, then we end up with the 11. So we plot those values, 0, 15. 0, 15 will be somewhere here. 119, 119, and negative 111. Negative 111. So we join those with 115, that is 119, and then 0, 15. So if we join this, then we are going to have a line. Let's have the equation again on the screen. The values, the equation that we are solving is we are finding the values of x for negative 2x. It is negative 2x plus x plus 9. Negative 2x, this is negative 2x plus x plus 9. The equation should be negative 2x plus 2x plus 9. So I think that should be corrected there. This is negative. So that this is now 0. Now we have this as 2x. Because if you go without a negative, you will not have a straight line. This is 2x. Then now we have 6. That is negative 3. So we have x when x is 0, we have this as negative 3. When x is 1, negative 1. This is now negative 2, negative 5. Yes, that should be the right values, negative 5. So we will now draw 0, negative 3, this point, then 1, negative 1, 1, negative 1, then negative 1, negative 5. Yes, now this is a straight line. You join using a ruler. Good. That is the line y is equals to 4x less 3. And so the solutions, as we've agreed, they are simply the points of intersection. You extrapolate to the x-axis. Ensure you show the extrapolation mark so that you can easily convince someone that you know what you are doing. So the values for x here will be with negative 1.9 plus or minus 0.1, or we'll have 2.2 plus or minus 0.1. Those are the solutions. So those are simply the straight line. Y is equals to 4x, 2x, this is 2, 2x minus 3. Thank you, this is 2x minus 3. So those are some of the sample questions that we can do in relation to this part of the topic. So now we need to look at what are your questions and your responses to our lesson. So we shall start with, this is Jeff from Embu. Jeff from Embu, is there any specific scale? No specific scale. The scaling or the choice of scale depends with the values that you have. That is what will determine the scale to use. Hi teacher, please repeat how you go to y-axis. Can one use a ruler to make the curves? Okay. One, it's supposed to be a smooth curve. The curve has to be smooth. And so in this case, use a free hand when you're drawing your curve. We only use a ruler when drawing straight lines. If they are straight lines, then you can use a ruler. Then we have Someone else, this is Catherine from Kitengela. Oh, thank you, you're enjoying the lesson. Munyonyo from Nakuru Pipeline, I have a problem in drawing a good curve. How can I do? If you want to know or get into perfecting your skills on drawing the curves, draw as many curves as possible and do regular practice so that you can make it perfect as you want. But the good thing is that when you start drawing the graphs, you follow the basics. Ensure always you have the required scale. From there, the curve will always come to be. Then, hi teacher, this is Purity from Syokimau. How do you know whether to subtract or to add? You know whether to subtract or to add by simply knowing what is the objective. The objective is to eliminate the squared. So if you can eliminate the squared by adding, then you'll add. If you eliminate the squared by subtracting, then you'll subtract. Crispus from Muranga, please repeat part C. When we add or subtract, I've already now said that. My request is for you to leave some assignment on quadratic graphs since I'm very poor in that. Okay, we'll consider that. What if on the same graph you are told to estimate the area bounded by the curve using the mid-ordinate rule? Then that takes us to Form 4, Topic 9, called area approximation. And you have to know what is mid-ordinate rule. You'll have then to identify the values of y at each of the ordinates, and area is either 1, review on what we call trapezoidal rule. Number 2, mid-ordinate rule, and then number 3, area by integration. So it is possible, again, you can look at also those other methods of determining area under the curve. Hello teacher, it's Purity from Syokimau. From a quadratic equation whose roots are those, you find now if you're given the roots, those not part of the graphs, but you can be given the roots to determine the equation. Like what she has asked is that you are given the roots of the quadratic equation. X is 2 less 2 root 2. 2 plus root 2. These are the roots. And when we talk of the roots, we simply mean the solutions to the quadratic equation. So to obtain the equation, simply take this to this side. So you have s less 2 plus root 2. Again, do the same to this. You'll have x less 2 less root 2. Then now expand this equation. Once you expand, that is now what we call the quadratic equation. Again, we have morning. When forming a table, you find a decimal value either for x or y. What do you do when plotting the same? That is Crispin from Siaya. Crispin, if you find the values of y are decimal numbers, then it is advisable that you record to 2 decimal places in the table. But now when drawing, you approximate the value to 1 decimal place. So we record in the table by 2 decimal places, but now when it comes to capturing to draw, you use 1 decimal place. This is the last one. Morning teacher, please repeat the point of turning point. I have not, okay. We've said if you have 2 points drawing a curve, this is a curve, you've marked this as the points. And at this point, x, let's say, for example, x here is 2 and x here is 3. There has to be a turning point because you cannot draw a curve na ufike hapa uchore hivi. So what you do is you have to get the turning point, and you get the point in between 2 and 3, there's 2.5. Now you substitute in the function so that you get what's the value of y, which you'll plot to become your turning point. I think those are the questions you've asked. Must someone be given the range? It is quite important to have the range, because without the range, then you'll not know what you are drawing. So we give the range for you to be able to know exactly what are the values you're supposed to use. So those are all that you've sent for our lesson today. And I thank you for being part of the lesson and actively participating in it. Continue drawing more graphs. Next time we will see if we can draw cubic graph functions. Thank you.